breaker. As you can see here, this LED is red now. CB close permission. So we have the permission to close the circuit breaker. So now what we will do, we will create a fault at 132 kV side. We will force a protection function from ABB relay. For example, the current protection function. This is the current protection function. So we will force this current protection function. Operate this current protection. Okay. So as you can see, it is showing trip now on ABB relay. So that means there is a fault on 11 kV switchgear side, and now we should not have the permission to close 132 kV. Sorry. See, this is 132 kV Ciprotec relay, and we don't have the permission to close 132 kV circuit breaker. So actually, all these are different conditions of only one signal. That one signal is 132 kV circuit breaker close permission. So multiple conditions are there in this signal. One is that the 11 kV circuit breaker should be in service position, that we checked. Second was that there should be no fault, that we have also checked. And what else? Then we have checked that the circuit breaker should be in the open state. That also we have checked. So different conditions, through different conditions we check this signal 132 kV circuit breaker close permission. Another last condition, not the last one, the third last, as you can see here, it's 11 kV earth switch open. So if the 11 kV earth switch is open, only then we will have the permission to close 132 kV. So now what we will try to close the earth switch and then see if we have the permission or not. Actually, in order to close the earth switch of 11 kV circuit breaker, as I showed you earlier, this is the hole to insert the crank of the earth switch. So in order to operate the earth switch of 11 kV circuit breaker, I have to rack out the breaker, the 11 kV breaker. So as soon as I rack out the circuit breaker of 11 kV, I don't have the permission to close 132 kV breaker. So there is an indirect interlock between the breaker and the earth switch, and because of that I will not be allowed to close the 132 kV breaker. So I hope you understand what I am trying to say. So actually what I want to check is, I want to close the earth switch and then check if I don't have the permission. So let's check this. Please hold the camera. So in order to operate the earth switch, I will have to rack out the breaker. So I will rack out. Down the breaker. Okay, the breaker is racked out. So, but there is another interlock from HP that I need to have the earth switch close permission from HP side. So that we already checked. So we will just simulate that so that we have the permission to close that. So. Okay, so I have to remove this line voltage. So I will remove this. Let's see. I don't now have the permission. Actually, in order to operate this 11 kV earth switch, I should have the permission from 132 kV side. That signal we have already checked, but right now the engineer is configuring that again to get the earth switch close permission from 132 kV side. 11 kV earth switch close permission from 132 kV side. This is 11 kV Ciprotec relay. That is on the other side is 132 kV Ciprotec. Okay, so now we have the permission to close Okay, so please hold this camera. Close that switch. I have closed the switch now. So as you can see here in the mimic, the switch is in the closed state. It's red. So what we were checking a signal from 11 kV switchgear to 132 kV switchgear. What was that signal? That signal was the permission to 132 kV side to allow the closing of 132 kV circuit breaker. But it was interlocked with the 11 kV earth switch. So if the earth switch on the 11 kV switchgear is closed, on the 11 kV incoming is closed, then we should not be allowed to close the 132 kV circuit breaker. So we'll check it. Do we have that permission or not? So, sorry, I will repeat it again. There was some signal interruption. So, right now I have closed the 11 kV incomer arc switch. So, what we are going to check is, in this condition, we should not be allowed to close the 132 kV circuit breaker. So, if you remember, earlier I stated that on the 132 kV Ciprotec relay, we have configured an LED for 132 kV CB close permission. So, as you can see, it's not lighted up, so we don't have the permission to close. So now I will open the arc switch. So now as you can see, it's green now. I have opened the arc switch. So we'll check again if now we have the permission to close 132 kV. So this is 132 kV Ciprotec relay, configured as 132 kV Ciprotec relay only for testing. So as you can see here, this is still I don't have the CB 132 kV CB close permission. Why it is so? Because the circuit breaker is racked down. The circuit breaker is racked down. As you can see, the circuit breaker is racked down. So I need to rack in the breaker also. On 11 kV side, I need to rack in the breaker. Only then I will have the permission on 132 kV side to close the 132 kV circuit breaker. So I will rack in the breaker. I have racked in the breaker. So the breaker is racked in now. Now let's check it. Now we have the permission to close 132 kV. So as you can see, this is 132 kV Ciprotec relay, and now we have the permission to close CB close permission. So this is 132 kV CB close permission. So now we have the permission to close 132 kV circuit. So that complete our check of this 132 kV CB close permissive signal. There were 4 conditions in this. I'll show you again. First condition, the 11 kV circuit breaker should be open. That we also checked. CB should be in service. That also we have checked. Earth switch should be in the open condition. Checked. And there should be no fault at 11 kV CB set. Then, if all these conditions are true, we get this permissive signal on 132 kV side. So this was the first signal coming from 11 kV and going towards 132 kV side. Now let's go to next signal. Okay. So the next signal in this sheet, it is signal number 4. So what's that signal? Again, this signal is going from 11 kV side to 132 kV side. Okay. So what's that signal? So this signal is an intertrip. If you can see the short description here, this signal is an intertrip to 132 kV side. Intertrip from 11 kV to 132 kV side. So, but on what thing? Let's check this. Mechanical trip at power transformer, or mechanical trip at NET transformer, or 51G fault trip at 11 kV breaker, or 11 kV breaker failure. So if any of these protections activate at 11 kV side, so then we will have a signal on 132 kV side to trip 132 kV side as well. So this is a signal from 11 kV to 132 kV side. So we will simulate all these conditions one by one. So we'll show you also the terminals. So actually all these protections in the 11 kV switchgear incomer, all these protections are inside the ABB relay. The ABB relay which is installed in incomer 1. So the mechanical trip, all the transformer related protections are handled by the ABB relay, and the ground fault is also in the ABB relay, and the 11 kV breaker failure is also in the ABB relay. So one by one we will force all these signals in the ABB relay. So what is the result? The ABB relay provides one summarized signal on its output, which is X110 card SO4 output. That signal goes to 11 kV Ciprotech relay binary input number 3, and from here the 11 kV Ciprotech relay sends this signal through a fiber optic link to 132 kV Ciprotech relay. So for this signal, this signal will be generated at 11 kV side from ABB relay, and can be checked at 132 kV Ciprotech relay on LED number 2. We have configured LED number 2 on 132 kV